Hello everybody. Today we're going to be looking at a problem from this year's invitational math exam. Um, it was problem number 12, and this is out of 15 total problems, and as most competitions, the difficulty increases as the problem number goes up, so this was a pretty difficult problem, and I actually solved this during the test. So for every subset T of U, which is the set of positive integers up to 18, let S of T be the sum of the elements of T, with S of the null set defined to be 0. This means just an empty set. If T is chosen at random among all subsets of U, the probability that S of T is divisible by 3. That's basically just what we want to compute. So, right, I'm just underlining the key points. So, when I look at problems like these and the sort of main setup, not really what the problem is asking for, but the main setup is just some random number like this. And I mean this for combinatorics problems. If it's some weird number like 18, then there's probably recursion, right? And I talked about recursion in my combinatorics series, where you basically sort of express a problem in terms of smaller, similar problems. And so that's what I'll be doing. So in fact, instead of letting this be U, I'm going to call this U sub 18. And that's unreadable, so U 18. And U sub n will be the set of numbers from 1 to n, like this. Now, another thing is that whenever you have a counting problem that uses some sort of number theoretic concept, like divisibility, and especially when it's divisibility by like a really small number, it's often important to consider sort of all possible analogs of this problem. And so what that means is that I will define P0, P1, and P2, each of which is the probability that, so P sub k is equal to the probability that S of t is congruent to k mod 3. And so obviously so any number, right? S of t is just a number, an integer, positive integer, and any of those will be either divisible by 0 or 0 mod 3, 1 mod 3, or 2 mod 3. So the sum of these probabilities has to equal 1. And another thing that we should figure out is what is sort of what we call the sample space of t. How many possible values of t are there? Because that will give us our denominator. In other words, how many subsets of u are there? And this is simply, you look at each element, and there's two options. It's either in t or it's not in t. And since there's n elements and two choices for each, there's 2 to the n elements of u sub n. Or I guess we should say, this is really called it's the cardinality of the power set, which is a set of all of the subsets, but I'll just say cardinality of t, or the sample space. Then we have to find how many of these subsets are divisible by t. So we have to find sort of how many are in this 0 category. And we know that all of the subsets in the 0 category, plus all the subsets in the 1 category, and all the subsets in the 2 category, those all add up to 2 to the n. And now, well, we haven't really talked recursion yet. We've sort of just been generalizing the problem. So for problems like these, where 18's kind of a big number, but it's not like super big. And for the AIME problem, since there's 15 questions on the test, right? And you have 3 hours, that's an average of 12 minutes per question. And you can usually get through the first 5 in about 12 minutes. So you have a lot of time to spare on these problems. So let's consider making a table where we have n. I guess what I'll just label 0, 1, 2, and then 2 to the n for reference. So let's consider a 0. Let's consider, for example, u sub 0, right? This will just make the pattern more obvious. There's going to be a pattern, spoiler. U sub 0 is just the empty set, which is this, and the only subset of the empty set is the empty set, and we define that the sum of the empty set was 0, which is 0 mod 3. It's divisible by 3. So we have one subset that is divisible by 3, 0 that are 1 mod 3, and 0 that are 2 mod 3. And this all adds up to 2 to the n, which is 2 to the 0, which is 1. Then for n equals 1, we can either have the empty set or the set containing 1. So we have 1, 1, 0. Then for 2, we'll have, we can have a set containing nothing or a set containing 1 and 2 that will give us 2 0 mod 3 sets. So the null set and 1 comma 2, both of those have a sum that's divisible by 3. And now we have one subset that's 2 mod 3, namely just the set containing 2. And then for 1, we still only have 1. Okay, not much of a pattern, but let's think about it. Notice sort of the recursion in the sample space, right? Each time the sample space is doubling. And that's obvious because our sample space is just 2 to the n. But on a broader scope, we're taking all of the sort of the t sub n minus 1, right? All the subsets of u sub n minus 1. And we say we either put n into the subset or we don't put n. And in this way, what we're doing is for any subset, right, that falls into one of these categories, essentially we're copying down because all of the subsets of u sub n minus 1 are subsets of u sub n, and they'll have the same 0, 1, 2, right? So these sequences are going to be non-decreasing, but then we're going to add some. We're figuring out what we're going to add. And this is actually kind of a bad step to show this, but so we know this has to add up to 8, but so 3, right? If we add a 3 to any of the subsets that are 0 mod 3, since 3 is 0 mod 3, the subset stays the same. In other words, here we have 2 plus 2. And then if a set is sums to 1 and we add 3, it's not going to change. It's still going to be 1. And if we add 3 to a 2, we still get 2. So we also have 1. So we have 4, 2, and 2, which does add up to 8, so that's good. Now let's consider adding 4, right? And 4 is 1 mod 3. So if we add a 1 to a 0 set, we'll get a 1 set. So the number of 1 subsets is the number of 0 subsets plus the number of 1 subsets. So that will be 6. Because I know this looks like a 1, it's actually a 2. So 4 plus 2 gives us 6. If we add a 1 to a 1 subset, we'll get a 2 subset. So we have 2 plus 2 is 4. And finally, if we add a 1 to a 2 subset, we'll get a 0 subset. So we have 2 plus 4 is 6. And again, 6 plus 6 plus 4 adds up to 16, as expected. And now we can just go over one more, because we've basically seen the pattern. Because if we add a 3, we're just doubling our entries. And sort of the way I got into, because I'm not going to write the entire table, I'm just going to skip down to what 18 is. But on the test, you have to, write the whole table, because you need each row to get to the next row. And I'll write in a few more patterns, but you see, like, sort of, you have X, O, O, right here. You have something and then two different somethings, but they're equal. And then for 1, you have X, X, O. And then on 2, you have X, O, O. And then 3, you have X, O, O. And then 1, you have X, X, O. Sort of that same pattern where, because you can't, like, it takes a lot of time to think about what you're doing each time. So if you get in the rhythm, you're sort of, each of these X's will just be an X and an O, and then this O is O plus O, and then to get this X is the sum of these two X's, and then each of these O's is an X and an O, so on and so forth. And so you sort of just start writing and writing until you get to 18. Alright, so if we add a 2 to a 0 subset, then we get a 2 subset. So here we have 6 plus 4 is 10. If we add a 2 to a 1, we get a 0, so we get 6 plus 6 is 12. And if we add a 2 to a 2, we get a 1. And so 4 plus 6 is 10 here. And these add up to 32, also as expected. And then again, once we add something that is 0 mod 3, we're just doubling the entries. And so this is the recursive pattern. And if you continue doing this all the way down until you get to 18, you will get the 0 entry. We're looking for the 0 entry. But the reason why we write all of these columns is because you have to have this one, or you have to have the other ones to sort of recursively define it. But once we get to 18, we only care about what's in this box. And what's in this box is 87424. Right, so now that we've counted the number of 0 subsets, we need to find the probability, right, which is P0. So that's just this number divided by the total number of subsets, which is 2 to the 18. And we need it in relatively prime fractional form. And since 2 to the 18 is only divisible by powers of 2, we have to essentially just divide this number by powers of 2 until we get an odd number. And if we do that, we end up with 683 over 2 to the 11, I believe. But notice that you don't need to know what n is, as long as you get an odd number, because you're looking for m. And m, sorry, is 683. And that is the final answer. And as far as I know, this is a unique solution. I mean, I came up with it during the test, and just from the solutions that are posted on the AOPS website, I haven't seen anything like this. So um, I assume, I mean, who knows? Someone may have come up with the same solution. A lot of people just straightforward counted the number, and it actually wasn't that bad to do, but I came up with this and I thought this was a really cool way of doing it. So anyway, just wanted to share that with you. Thank you for watching, and I'll see you next time.